This is a small strip thin gap chamber, or sTGC, and we'll discuss why they're called that. But first, notice here how there's 4 layers. Each of these individual layers is an individual sTGC. We call the whole module a quadruplet or quad because of the 4 layers.
Each layer contains a small, thin volume of gas. If we zoom in on one layer, we see wires suspended in the gas. The bottom plate defining the gas volume is segmented into pads. We apply positive high voltage to the wires suspended in the gas, which creates an electric field in the gas volume. The volume is closed by a top plate, segmented into strips. I've only covered half the volume here so you can see what's going on inside. The wires, pads, and strips are called electrodes. Turning on to a front-on view of the gap, when a muon passes through, it ionizes the gas. Thanks to the electric field created by the wires, the positive ions drift towards the copper plates, while the electrons drift towards the wires. The motion of the ions and electrons creates small current blips in the nearest electrodes, one of which would look something like this. So, if a muon passes through this pad, this wire, and this strip, we would get a current blip on all 3. The wires and strips form a grid from which we can extract the position of the muon as it passes through the layer.
Alright, so with the 4 layers of each quadruplet, we can actually reconstruct the track of the muon using the information that we get from each of those 4 layers.
The next question is, how do we read out the current blips from those electrodes? Small current pathways called traces exist in this green printed circuit board, 1 trace for each electrode. Those traces bring the current blips here to the front end boards. The front end board has to process all the pulses of current and send them off to our data acquisition system. These 3 black chips are called VMMs. They each contain 64 channels, some of which connect to the traces in the green circuit board that connect to the electrodes. Each VMM channel will measure the current blips that come through to it and give us key information that allows us to reconstruct the muon's position. Once the wheel is covered with detectors, each quadruplet's layer's grid of electrodes will create a coordinate system to track muons through any spot on the wheel.